Sequences. There are 4 different types of sequence we're going to be looking at. An arithmetic sequence, quadratic sequences, geometric sequences, and Fibonacci sequences. Let's start with Fibonacci sequences. You're not expected to be able to determine the nth term of a Fibonacci sequence. You just need to know that a Fibonacci sequence is where the next term in that sequence is the sum of the previous 2 terms. So looking at our example of 1, 1, 2, sum means to add, so that's 1 plus 2, that gives us 3. 2 plus 3, 5. 5 plus 3, 8, etc. A geometric sequence. Again, not expected to know how to find the nth term of a geometric sequence. It's knowing that a geometric sequence is that there is a common term-to-term multiplier. We can see in this sequence our multiplier we have multiplied by 4. So our next term in that sequence we will be doing 16 multiplied by 4, which is 64. If this were some form of algebraic sequence, for example, let's say we've got x plus 1 and then the next term in the sequence is x. And we wanted to know what the following term in that sequence is. Well, what we'd have to do is just here, as 16 divided by the previous term of 4 tells us what our multiplier is. So here we would do, well, x over x plus 1 would tell us what our next term is. So if we were to multiply x by x over x plus 1, remember our fraction rules, x times x over x plus 1, and we times straight across. Our next term in this particular sequence would be x squared over x plus 1. So they can be algebraic. Now let's look at our arithmetic sequence. Now here we will be looking at trying to find the nth term of an arithmetic sequence. So this is just where n stands for the number of that term in the sequence. So it might be the 4th term, for example, where n is 4, or the 18th term in that sequence. So our first term in this sequence is 2, our second term is 5, our third term is 8, our fourth term is 11. With an arithmetic sequence there is a common difference, so 5 take 2 is 3, 8 take 5 is 3, and 11 take 8 is 3. So we are adding 3 each time. So we could say our next term in the sequence is 14. Using this to find the nth term, whatever that difference is, we place that in front of n. 3n. Now, here's one way we can do it, is we find the 0 term. So we go back 3. So that's 2, take away 3, which is minus 1. So our nth term is 3n minus 1. Or another way we could do it is, let's say n is 2. So 3 multiplied by 2 is 6. But 6 is not the term in the sequence, it's 5. We would have to take away 1 to get to 5. So we know our nth term is 3n minus 1. What's the 20th term of this sequence? Now you've found the nth term, you can use that formula because we can then find the 20th term. So 3 times 20 minus 1. 3 times 20 is 60, take away 1 is 59. Now, is 35 a term in this sequence? What we don't want to do is just continue our sequence all the way up because we might have a really large number. We use our nth term. So we can say, well, if 3n minus 1, if that equals 35, we can find out what n is and therefore what term in the sequence 35 is. So we add 1 to both sides. That leaves us with 3n equals 36. Divide by 3, n equals 12. It's a whole number. So yes, 35 is actually the 12th term in this sequence. Now, a quadratic sequence, very similar to a quadratic equation, that's the form that the nth term takes. So here is our quadratic expression for our nth term where a, b and c are integer values that we need to try and find out. N is the term in the sequence as was before for the nth term. Now how we try and find out a, b and c. Now quadratic sequences will be on higher papers only. We start by finding the difference between the terms. 11 minus 4 is 7. 22 minus 11 is 11. And 37 minus 22 is 15. What we notice here is that all of these differences are different. So we go for the differences between those. 11 minus 7 is 4 and 15 minus 11 is 4. So with quadratic sequences, it's the second difference, the difference between the differences that are the same. Now how this helps us find values of a, b and c. Here are some formulas to learn. 2a is equal to the second difference. 3a plus b is equal to the difference between the first two terms. And a plus b plus c is equal to the first term in the sequence. Now where these come from are actually an A-level maths algebraic proof, so you don't need to know at GCSE where these rules come from. But it's helpful to know them because it's a really nice, tidy way to write down a quadratic sequence. We have to start at the bottom because we need to find the value of a first before then we can put it in here to find the value of b. So if 2a equals 4, a must be equal to 2. 3a plus b equals 7. Well, we've just found the value of a to be 2, so we're going to substitute that in. That's 3 times 2 is 6, plus b is equal to 7. So b must be equal to 1. And then a plus b plus c is equal to the first term in the sequence, which here is 4. We know a and we know b. So that's 2 plus 1 plus c equals 4. So that's 3 plus c equals 4, so c must be 1. And now you've found your values of a, b and c, we substitute that back into our nth term form. So that's 2n squared plus 1n plus 1. And that's our expression for the nth term.